All right, today we're going to talk about database design. We'll go through some basic concepts on that. We've already covered a lot of this stuff already, and as we go through the process. So, some of this may seem like deja vu all over again, but that's okay. It's worth repeating. Let's see where we are in our syllabus for now. Oh, one quick announcement before we get going is that the hard drive crashed on my computer in my office, and I just got it back yesterday afternoon, and fortunately for me, they were able to recover all the data on the thing, and I didn't realize how much stuff I had stored on that thing, but I've been here almost 7 years, and that's a lot of stuff. So anyway, so as a result of that, I'm behind on grading. I have a midterm that I have to do, and I have 2 projects that I have to do, and so I will be hiding in my cave for the next couple of days trying to get that cleared up. So what we have left here is, all right, we have this week, we have database design basics. Next week, we have the system specification questions for your simulated meeting with the owner of the marina, right? You're going to ask them some questions, so you're going to read it over and submit your questions. I will post a general response to those. And then the only thing we have left will be, so we have, let's see, the 13th is what day of the week is the 13th? That's a Sunday, right? Must be a Sunday. So that means the 20th is that's the week before Thanksgiving. So we'll have a little bit of a break. Geez, how did I get so lenient on you guys? Give you a week off before Thanksgiving, then Thanksgiving week. Hope you guys don't get lax in there in that time. But anyways, database design basics, system specifications. I would use that week to, if you have questions on the project after the 13th that week, email them to me Monday, Tuesday, and then I'll come in here and record some answers to those questions so that everybody can have the benefit of whatever questions you have. Fair enough? Fair enough. All right. Let's look at this. I'm going to just use this as a roadmap to make sure I cover all the important stuff. Okay, database design. I had a professor in graduate school who was a retired vice president from IBM, and he used to have programmers and developers working for him, and he had his philosophy was you should spend 80% of your time in design and 20% actually getting on the computer. And he used to tell us, don't get prematurely physical with your computer. Stay with the design, and when you think you have the design done, bounce it off someone else. Try to get some feedback. Let somebody play devil's advocate. Ask yourself some hard questions. It's hard to do sometimes because when you're creating something, you're designing something, you don't want anybody to touch it, you don't want anybody to hurt it. Don't hurt my creation over here. It's fine the way it is. Let's let everybody just do the way we're supposed to do, and everything will be fine. But that's not how the world operates. Somebody tears it apart, you should thank them. Thank them, because it will make the end product that much better. So what we're doing at this point is we're going to transform the entity relationship diagrams into relational designs. So basically you're starting to normalize the data in a way where these tables start falling out. Now I would tell you, and you've probably seen this already, that most times the entities in the ERDs, those boxes, translate into tables. But it's not always the case. It's not always the case. So as a first cut, yes, but you may run into a situation, particularly if you find in your ERD you have a many-to-many relationship that you left in there, you're going to breaking that down further and further. So you need to just be aware of that. In general, in simple systems, Typically, the ERD breaks, each one of those entities breaks down into a table, and then you put in fields to describe what each thing, like a student or a course or whatever. All right, so we'll talk about denormalization, which is the opposite of normalization, but we'll talk about both of those. And weak entities, we talked about already. We did that with the building and the room. If you have a room number on campus, you need the building code in front of it to uniquely identify the room. That is, the relationship between rooms and buildings is weak, that you need the building code in order to uniquely identify a room. Okay, we've done that. And we've also done the how to represent one-to-one, one-to-many, and many-to-many relationships.
I have a question for you.
Yes?
When we're doing the one-to-one, many, you explained this to us once before, I just have forgotten. How does the system know if it's one-to-one, one-to-many, or many-to-many?
The system knows because if I have so let's say I'm in Access and I'm on that relationship screen, right? And let's say I have a customer table here, and I have a customer ID here, and it's a primary key, and it's defined that way, and it's related to some table over here, well, whatever that is, and down in here I have a customer ID as a foreign key. It's pretty simple. If this is a foreign key, can it repeat itself? Can I have repeat values the same? Yeah, sure can. Because if you're a customer, you're going to buy something today, you're going to buy something tomorrow, you're going to buy something the next day. Your customer ID will be in all three of those transactions. So it will, by necessity, repeat. When they try to figure out your billing address and they go back to the customer file to figure that out, how many times are they going to find your customer ID? How do you know that?
Because you only have one billing address.
I only have one.
Primarily can be done one time.
Because customer ID is a primary key, so it knows it's going to find one and only one here. And since it's not a primary key over here, it knows it can find many. And the question is whether it's a one many or a zero many. That's where the refinement comes in. But the system knows that it's a one or a many based on whether it's a primary key on one side and a foreign key on the other side. Foreign keys can repeat, primary keys can't. That's how it knows. And if it's not a primary key over here, it's just a field, then it'll show it as a many-to-many, because it doesn't know, even if you're only going to have one in here, say you were using email address as a primary key, and customer ID was just there, even though it doesn't know that that's a unique field, it would say, well, this customer ID is here, and it's here, and this is not a primary key on this side, not a primary key on that side, then it's many-to-many.
But normally, all the tables that we've done, we've always connected the primary key to the form.
Yeah.
So is there going to be a time when we don't connect the primary to the form? Or we just do basically what is the name I'm looking for? Where it's possible to be a key, but it's not a key.
Candidate key?
Will we possibly connect the candidate key to another? Would it be a foreign over there still? Because the candidate over here and it comes over here. Is that a foreign to candidate at that point in time?
Yeah, I guess it would be, yeah, foreign.
Would you connect them to, I would say? Or are you always going to do the primary to the foreign key when you do the relations? Sometimes you don't. Well, here's the thing. When I was in college, back in the early 80s, my university used our social security numbers as our student ID. It was on our ID cards. Talk about totally different world back then. This was long before identity theft was ever the problem it is today. But I had my student ID and it had my social security number on it and my name. So if somebody wanted to and had the gumption to do it, they could have stolen my identity. There was 3,000 students at that university had the same thing. They finally, just about the time I left, they stopped doing that because they were advised by their lawyers not to do that for good reason. So they had to create a student ID number. Now, if you had financial aid, the link to your financial aid file
was your social security number. And even though that wasn't public, it was in the system that they had, the financial aid system needed to know your social security number. And so it had to have that in order to connect. Now, my social security number is unique to me, but the system didn't really know that. The system just knew to go and find a social security number over in the student's file here somewhere so that I can find the other information. My social security number was not my primary key in that file. My student ID number was. But I needed the social security number to link to financial aid. The financial aid people with the federal financial aid departments, they didn't care what my student ID number was. They could care less. But if they knew if they had my social security number, they could find me. Does that make sense? So in that case, social security number was not a primary key in either table, but it was, so I would have this loan, that loan, it would be a primary key over here would be loan number, right? Loan number 1, loan number 2, and loan number 3, all connected to the same social security number, which would link back over to the students table. That students table, that social security number was not a primary key, but it did happen to be unique. Does that make any sense?
Yeah.
So that does happen. Just let that marinate for a while, see how it goes. All right, transforming data into relationship design. Now, in the system that we're working on for our project, chances are you're going to have, by this point, you should have kind of a sense, and we're working with data that's relatively easy to transition from design to database. It's pretty easy, and I think once you get into it, you'll see there may be some subtle things that you might be able to do as far as normalization, but for the most part, it should be pretty straightforward. Okay. Column properties, yeah, and then analyze normalization rules. Let's get into the normalization. All right, this is just review right here. Remember we did these? These little diagrams here, the item table, right? You get the table name over here. What's the underlined field?
Primary key.
Primary key. That's all right. You're on the right track. Then you have these other. So this is a candidate key field at the very beginning, and these other fields are determined by this one, right? So the item number determines what the description is. If I use item number 1, that means it's widgets. Item number 2, hoses. Item number 3, clamps. So the item number determines the description and the cost and the price and the quantity on hand. Those values are determined. We look to find those values. This is how one way you can think about it. To find out this other information about description, cost, list, price, and quantity, if I know the item number, I can get that. So the item number determines those other values. Does that make sense? All right.
The item number is a primary key though, right? So
Yes.
when we did the example where you had like bolts or like item number 1, it's like 5 different bolts. And then like you have item number 2 is screwdrivers or whatever. So how is that a primary key and it's gonna pull up multiple things? So like for instance, if I pull up item number 1, you might have 16 different bolts. So you're gonna pull up all the bolts.
Now you'd have a different item number for each each type of bolt. So you wouldn't just say bolts in general and then.
You have a different product, and I can put a product number, make that different, the item number still will be different as well, right?
It would be different. Mark, if you go to Lowe's or Home Depot, you ever go into those bins where they have all the loose nuts and bolts? Put them in a bag, and there's a little number on the bin. You have to write that number on the bag. Once in a great while I go in there and do this stuff. But each one of those is different. If I have 3/16 washers and I have 1/2-inch washers, they have a different number. And they should, because you can't just say washers in general or bolts in general, because what kind of bolts? You want to know what kind of bolts.
Right, because I've seen them do like the same item number though, like item number 1, which is like the washers, and and then have 7 different product numbers, like for 7 different size washers.
Well, then the product number would be the primary key, because that uniquely identifies the different sizes and types. Yeah, so you would always want to make sure that if you have, half-inch bolts, quarter-inch bolts, those things are different bolts. They're both bolts. I'll hand you, just like cars, Chevys and Buicks and Toyotas. You wouldn't say, well, they should all have the same product ID, so therefore, no, they're different. In fact, every car is different. All right, so what we do here is on the under A here, the item entity, and you notice, see how this is one where it translates very well to a table. So the table, the item table, the item number is, you get the little gold key there, and all the rest of the fields. And here's the detail, or the metadata. Has your book used the term metadata?
Once or twice.
Data dictionary?
Huh?
Data dictionary?
No, they use metadata, but they basically said that it's data that describes data. That's what they said once or twice in the book. We didn't get reviewed into it.
Okay. The metadata, or the data that describes the data, is this stuff. Item number is an int. It's the primary key. It's whatever. The description is a variable length character up to 100, and it's not null. That's metadata. It's the data about the data. These are the fields, and here's the types of fields they are. Cost is numeric. It's 9,2, which means it's overall 9 length, 2 decimal places after the 2 places after the decimal, not null. That's what they mean by metadata. Sometimes you'll also hear it described as a data dictionary, which describes the structure of the table. All right, so this is the detail. So your step 1 is your ERD on the left. Step 2 is your basic table design on the right. Step 3 is the more detailed description of the table, where it has the data types and the lengths of the different values for those fields. Okay, you see how the progression gets more detailed? Okay. All right. Tables are not normalized. All right, we did normalization before, didn't we? We talked about insertion, modification, and deletion anomalies. Did that? I think that was a long time ago.
We did
Like week 3 or 4.
SQL coding for the insertion, modification, deletion. Are you talking about when we're doing the coding on it?
I think it was before the coding part.
For the normalization, we did do that part where you basically look and see if it's a possible, I don't know why I'm losing the word today with the C, not primary key, but it's a contingent.
Candidate key?
Candidate key, and if it actually describes or actually one has an effect on the other, then you take that out, make another table. So it's saying something like that, like if one determines the other one, then you take that out, and you put the two in another table, one becomes primary key.
Right. So when you normalize it, if you have 2 fields that are candidate keys, I'll give you an example. If you have a student ID for a student, and that student has an address, right? So the student ID determines the student's first name, middle initial, last name, and the street address, and the city, state, and zip is part of the address. But you can't have somebody live in Apollo Beach, Florida, so you have Apollo Beach, Florida, and then have the zip code for Portsmouth, Rhode Island. Zip code for Portsmouth, Rhode Island is 02871. If you send that person a letter, it's going to go to Portsmouth, Rhode Island, and it's going to see if it can find that street address in Portsmouth, Rhode Island, because the post office uses the zip code to determine where it sends what city and state it sends the letter to. So zip code determines city and state. So that's a candidate key for, so city and state depends on zip code more than it depends on student ID.
So in that one, you would have the zip code, city, state, and the address, correct?
So in that case, you would take, if you really want to fully normalize it, and sometimes, I see this sometimes when you buy something online, they don't have you type in your type your street address and zip code, and it fills in your city and state. Has anybody seen that? So just want your zip code. Don't you want my city and state? No, I'll have it in just a second. Give me your zip code, 33572, Apollo Beach, Florida. How about that? It looks it up. So that you can't, the idea behind that is to not have an anomaly where the zip code doesn't match the city and state. Doesn't make any sense. You gotta, try it sometime. Just send a Christmas card to somebody. Christmas is coming, right? Send a Christmas card to somebody, and let's say they live in Oxford, Pennsylvania. Good. And just make it like, whatever the street address is. It's even funnier if the same street address existed, say, in Tampa, right? And put the zip code, you put Oxford, Pennsylvania, and put the zip code for Tampa, and see if somebody in Tampa gets a Christmas card from you because it didn't actually go to Oxford, Pennsylvania. I will bet you a donut that it will go to Tampa and not Oxford because they don't read the city and state anymore.
So the physical address part is actually going to be determined by the zip code too?
The street address, so that it gets mailed and it goes to Tampa, and at the post office in Tampa, they look at it and say, all right, does this street address actually exist within this zip code in Tampa? If it does, they're getting a Christmas card. If it doesn't, it goes to what do they call it, the dead letter box somewhere where the wayward mail, was it the Island of Misfit Toys? The Island of Misfit Mail gets left, and I don't know what they ever do with that,
A lot of times we just reject the return sender.
Return sender, there you go.
Some people want to repost, send a free letter that way.
Oh yeah, well they reverse the
Just reverse the whole process. All right, so no more stamp.
yeah, stamp's only 50 cents, right, or whatever it is.
Yeah, it's a crime.
Yeah.
What do they do?
They put the address that they want it to go to.
Like the sender.
So if I was going to send something to you
Right.
and I don't want to pay for it, what I'll do is I'll put my address as the address to, and I'll put your address as the return to. So it goes into a mailbox, doesn't have any postage on it, so it gets sent to the return address, which is yours. And so therefore I send you a letter without having to pay for it.
People are they're just too smart. Seriously, dude. Like, who has time to sit down and think about that? Like, that's...
I'm not advocating for that, but I do have an opinion on that, which is if people can spend this much brain power thinking up ways to send free letters, why don't they go out and get a job? You gyp the government out of what, 43 cents? Or I don't know how much a stamp is nowadays. But what, now you can retire and move to Miami? Come on. Go get a job. Use that creativity for something good.
I think that just with the whole entire thing, I think the only issue I'm really having is I haven't done this so long as primary keys, just establishing which one's going to be primary. Because I do have a question. While we're doing primary keys and getting on that tab, when you were doing remember how I originally made everything touch in a circle? I was making everything do the primary touch the foreign, they have the primary touch another foreign. You said you don't have to do that. So basically,
Doesn't have to be a circle, but they do all have to be connected to something.
so basically I can have this one here, a primary touching the foreign over here, right?
Mhm.
And then I can have this one over here, and that primary doesn't have to link to a foreign, it has to link to a foreign over here, right?
Yeah, most of the times it will, yeah.
So basically, I can have 2 or 3 different things coming out that original table, touching 2 or 3 other tables out,
Mhm.
need to be.
Mhm.
Then I have something come over here, over there.
Mhm.
That's the only issue I have is when I'm building it from the get-go. Like, I'm starting to learn this SQL a little bit better, and normalization, I don't think I have too much issue, just only when I gotta do like a composite key, not composite, yeah, when it has like 2 or 3 different, keyboards, I gotta make them right. So other than 2 things, I don't think I have an issue, but.
Let me give you an example, which is right on the, let's say you have a customer table. All right, well, let's say you have an employee table. And let's say you have an inventory table. Inventory. Then you want to sell something. Your sales table is where a customer buys something from you. The employee sells it to them, and they sell them something. So if this was cars, here's your car salesman over here.
Here's your customer over here. Here's the Toyota that they just sold them right here. And those are all related by a sales table in the middle.
So the sales team is gonna have primary key and probably 2 foreign keys reaching out for them. So it's possible that sales table has 2 foreign keys.
Sales table will have a sales ID number. Or you look sometimes on a receipt, it has a transaction number on there. So like if you go back to Walmart, they'll scan that barcode for the transaction number and it'll pull up the whole receipt so they can look at each item on there. That's a primary key only for the sales table. That primary key is not a foreign key anywhere else, probably. But my employee ID over here, right? My employee ID shows up over here as a foreign key. It's a primary key here. My barcode is a primary key over here, but it shows up over here as a foreign key. My customer ID over here, which is a primary key, shows up over here as a customer ID as a foreign key. Foreign, foreign, foreign. None of them are primary keys. It's a primary key here, primary key here, primary key here.
So the sales, you actually have to do like an auto number, or you could just do.
Yeah, I'll bet it is an auto number. Just they don't care. They just need a number so they can access it. So my point is, and then in a more complex organization, you could have other ones, other things over here, around. Now, these things do not connect in a circle, but they are all connected. Got it? And typically, when you have some kind of a transaction table, that's where you see this. The transaction table pulls together customers, some sort of outsider and insider, customer and employee, and you're going to sell something, inventory, and then you might have, something else coming in there too. Like doctor's office. Patient, doctor, meet at an appointment. All right, so we're talking about insertion, modification, deletion problems. We talked about that when we talked about normalization originally, but the result is we get things like this. All right, solving modification, functional dependency. I want to see if we tells you what each normal form. First normal form, second normal form. Now, they talk about in your book third normal form and Boyce-Codd normal form. I have not seen a database that breaks it down anything beyond Boyce-Codd normal form, and most not beyond third normal form. This fifth normal form, domain key normal form, these are more theoretical than anything else, than something you would put in a database, because you're pulling apart the data so much that it makes it hard to take a snapshot of data the way it is today. Those ERP systems we talked about, you guys heard about those? Marcus, we talked about that, right? This SAP, you had a thing for an internship with SAP.
Resource planning.
Yes, those systems, enterprise resource planning systems, those systems are mostly second normal form.
So they basically they have this and they break it down and they break it down again.
That's right. And some parts of it would be third normal form. And the reason is they actually denormalize the data. What they do is they pull it all in, like this diagram here. They pull it all together. And then what happens is they create a document where they pull in all the dependent data from the employee, the name, the badge ID, and all that stuff, and the customer information, their name and shipping address and all that stuff, and the inventory description and price. They pull all that in and they create a document here, and they save the document. It's like a big receipt, and that document has an ID number. The same way at Walmart, when you buy something and they have a receipt ID number on there, so they can pull all this, it pulls up that document. So what that allows them to do, by denormalizing the data that way, they're storing the employee information in multiple locations, they're storing customer information in multiple locations, and the description for the inventory in multiple locations. But it gives them a snapshot. Today, this employee worked here. Today, this customer lived at this address. May not live at this address a year from now, but he lives at this address when he bought this stuff. And that inventory, we had that inventory on hand. We were carrying this. Maybe we discontinued it 6 months later, and the price of it at this time was this price. That price also may change as time goes on. So if you left the data completely dynamic and you tried to reconstruct something based on the relationships for the data, it may find that this employee doesn't work here anymore, or he's in a different department. And it may find that this customer has moved, and it doesn't give you an accurate reflection of what the data looked like on the day that the transaction happened. That's valuable. Having it update is misleading because it makes it look like you made more money because the price went up. I didn't get the price. This guy bought 100 widgets from me, and they were 10 cents a piece. So I got $10 from him. Well, it went up to 25 cents a piece 2 days after he bought this. I didn't get $25 from this person. I got $10 from this person. See that? So it would cause update problems in another way. See the difference? So there's SAP systems, ERP, and PeopleSoft and Oracle. They actually create documents where they pull in all that extended data, that dependent data, and they create a document with all that stuff on there.
So it's almost like they create a form. Not
Yeah.
a form, but a report.
Yeah, it is a report. A receipt is a report. So they create this report where this one transaction is put into a document and it's stored. So if I need to review that document again, I can scan and pull the whole document up, and it has all the prices and everything is just the way it was on the day of the transaction.
Basically, it takes all entity tables and all their information on the tables and puts it on one big document.
Right.
Wow.
So then if that related data changes down the line, I still have a snapshot of the way it exactly was today. I don't lose that. So the reason why we normalize stuff is to eliminate modification anomalies. But if you make it completely dynamic and completely normalized to Boyce Codd normal form, then I get modification anomalies the other way. You see that? The price goes up, and then all of a sudden it makes it look like I made more money, and I didn't make that money. So typically, second, third normal form. Third normal form is where you're breaking out, third normal form is where you're breaking out the zip code into a separate file. That because all candidate keys have to be broken out.
Yeah, that's when you bring in the zip code, the cities.
I'm trying to think off the top of my head what difference between that and Boyce Codd normal form is.
Well, the way they explained in the book is just basically everything you break down, it goes another level. And then there was like saying like if it's under a certain percentage or something, oh, here's right here. They wrote it down some kind of weird way, and I thought there's that way, but it was no funky stuff. Let's see here.
Oh, here we go. Boyce Codd normal form. Every determinant is a candidate key. That's the difference. That's where you break out the zip code. Boyce Codd. But I've never seen a database broken down any more to a higher level than Boyce Codd normal form. Never seen it. Maybe I'm not saying that there aren't any. I'm just saying I
Every
never.
determinant is a candidate key at that point in time.
Mm-hmm.
So if it just determines one other field, it's a candidate key.
Yeah.
Instead of determining the entire thing. Wow. Because normally in order to be a candidate key, it has to determine every field.
Every determinant. So if I leave city, state, and zip in my customer file, that's not Boyce Codd normal form because zip code determines city and state. So
every determinant, so zip code is a determinant, must be a candidate key. So making a candidate key, I would put that into another file, and I would set up a relationship, another table. I would set up a relationship. Okay? And this right here, they're using it, that exact example. Zip code determines city and state. So they would say, do it this way. Have a zip code file. And your post office, there is a way, actually, in my Python course, we accessed it. Online, I forget the URL, online you go to the U.S. Post Office and you can get a table of all the zip codes in this country and what city and state they go to.
There's like Kansas, Florida, Temple, Kansas, and Temple, Florida. They have different zip codes.
There's Miami, Ohio, Miami, Florida.
Yeah.
There's Gloucester in about 5 different states, Bridgewater, and there's Portsmouth, Rhode Island, and Portsmouth, New Hampshire that are like an hour and 45 minutes from each other. There's Bristol, Connecticut, and Bristol, Rhode Island that are about 45 minutes from each other.
Wow.
Bristol, Tennessee, where they had the NASCAR race. So yeah, we didn't get too creative. You know, they're not exact. So many cities didn't get too creative. Denormalization, we talked about breaking things down into a document, which then stores all that stuff denormalized. But it's okay because you're not going to modify or delete that data. You're saving it as a for historical purposes to accurately describe what happened at a certain point in time. So you denormalize the data then because the data is static. It's not dynamic at that point. Data that is dynamic needs to be normalized because it's changing, right? You want to update prices and things like that. How many I have on hand, that's dynamic stuff. Once I have a sample of data that is static, that's not going to change, then I would denormalize it and store it with all the related information.
So if you're going to change a price, for example, on inventory, and you don't want to change on the sales option because I think we had something like this. You don't want to change on the sale because the sale is already final. So,
Right.
So you would not link that price. You would link, even though they both have the word price in them, you would link them two together. Is that correct? Because if you change one, and then it automatically has to change the other one, right? A cascade at that point, right?
Right, you wouldn't want that to happen. If I create a sales document, I would store that document someplace else, right? This document I create, all right, now I'm going to put it somewhere in a file. It's supposed to be a file of documents, sales documents, and these are going to be pictures of something that happened. These are not related to anything. They're just accessed that way.
So if we create, but that's what the cascade for, right? If you were to create a relationship, I guess my question is, if you don't have a relation tied to two different things, so for instance, I don't think I can go back into his price, but if you are teacher's pay, okay, and you change it in one area, does it automatically change in all the other areas? Or will you have to go back and change it in the other?
No, it should change it in where the data is dynamic. Here's the area where the data is dynamic.
You have to
All right.
create a relation between them two only though, right?
This, if I change the price on something here,
Right.
right, the price changes here. When I sell the next one, the price is going to change there because it's going to read it from there.
And that's only if you create that relationship though, right?
Right. I did create the relationship. The barcode here is it relates to the barcode there, and it allows me access to everything else.
Okay, so that's my question, was why you create a relationship with the barcode, even though you only got a relationship directly with them two, if you change the price, it still changes because that relationship creates it for everything in that table? Is that basically what you're saying?
Mm-hmm. So that relationship lets you access everything about that item. If I swipe a barcode at Walmart and it says dog food, Purina 1, 10-pound bag, $11, all that information describes the item that's related to that barcode. The barcode determines what the description is, the size, the price, the weight.
So then that goes back to the question. For instance, I know it looks like it was crazy, but we have the BC barcode, we have the dollar signs for the amount of money, and then we have price up under that, right? So if you want one of them changed, such as the price of the item, but you don't want the other things to change down there, how you're able to do that. So, you understand what I'm saying?
If I want the price to change but nothing else to change,
Right, because you're creating a relationship between the two tables, right?
right, well, then I just change what I need to change.
I'm not following you there.
I don't think I'm following you either.
Only changing one item in there.
Yeah, you're only changing one item. I'm going to have, a barcode's going to be 1, 2, 3. The description is going to be dog food. It's going to be 10 pounds is going to be the size. Price is going to be $11. Then I'm going to have another one, 2, 3, 4. It's going to be cat food. It's going to be 3 pounds. It's going to be $4.
Right.
So if I want to change the price to dog food, change the price to dog food.
And that changes for all the other tables, that dog food.
Wherever that's going to be used from this point forward, whatever is going to be related to this barcode, from this point forward is going to read the new price. Because it's going to come in, it's going to find it, it's going to read that, it's going to read that, and it's going to read that.
In case of clearance or apply coupons, they will directly impact.
Yeah, the coupons are going to be pretty much handled at this level here. Because it'll read that price and pull it in, and then it will discount it, right? So, or if you have depending on how they handle coupons.
The verification condition met, move forward.
Yes, it'll find that, it'll subtract from that.
With the new kiosk, they even added a lot of the weight limitation. So you can check out yourself, but the counter, the weight will have to add on top of another item, and they just bug you like have you put the things in the basket? If not, store attendant have to log in.
Yeah, and what they do is when you put it on the belt, it weighs it, and then you scan it, and then once it's in the bagging area, and it checks the weight to make sure the weight's the same.
It's a pain.
I want to know why, this is my personal gripe, why am I not getting an extra discount on my food at Walmart if I check myself out?
It's outsourcing to customers.
Because they're getting a discount on payroll because I'm checking my stuff out. Just my own personal gripe.
I understand what you're saying now about that. The only other question I would have about it would be back to like if we wanted to, but that's the sales right there, right?
Mhm.
So if we change something in the inventory, it's gonna change everything on there because we have a direct relationship to the barcode, right? So how would you stop it from changing the sales itself? So we change the price over your inventory. How do you stop it from changing the sales at that point in time? The sales has the price inside that table as well.
Right. Once you finalize the sale, what you then have to do is create that sales document and store it.
So first of all, when we're creating our tables and we have, sales, we have 10 sales laid down, right?
Mm-hmm.
And one of our problems were, that's why I asked the question, is because it says change your price in inventory and go and look and make sure that your price in sales has not changed. It was one of the questions, basically. So I was trying to figure out how we're gonna change the price in inventory and then go right to the sales table. And it's changing the price in the sales table too because they're related. And I just don't know how to do it. And I know normally if it was the primary to foreign, you can go directly in there and unclick Cascade. But the price itself was not what we were linking. We were not creating a relation between the pricing.
What you could do is, in this case, you would then add the field for the price here, and it copies it from there to there, only when you first look up the barcode. So if you change the barcode, it would then go do the lookup again. But as long as you don't change that barcode, it's what did they, in that book, did they get into record level validation?
No, I'll find it for you, and I'll see your email, but it was one of our, it wasn't a workbench, I think it was one of our things after, the week after we usually do the turn in for our homework or whatever. I think it was one of our homeworks, so go in here, it was back here, it had us. change something, and we have to actually draw it out, like a matter of fact. We have to draw it out of how we're gonna change the price here, but it does not change the price inside of the other table.
Then it would-
Already linked.
What it does is it can copies it and stores it again, so it duplicates it. So it denormalizes the data because it's duplicating that, because that way it will use the value that it copied, and then if it changes in the table, it doesn't cascade to the new table. That's a real problem for I mean, sales, especially stuff that changes, like, look at, like commodities traders and things like that, or the price changes every minute, or currency trading. It changes every minute. So when they record the price, they agree to sell something at a certain price, and they have to capture that price right away and create a document for selling that thing, that commodity, and because that's going to change again. They don't want to read it a second time. So then they create this document that has all the sales information. But anyway, let me move on, because I want to get through some of the stuff here, make sure. Okay. Weak entities, we talked about this before. We use the building and room. They use invoice and line item. That line item can't exist without the invoice number. So if you have an invoice and you have 10 different things on that invoice, those individual line items are only meaningful when they're related to the invoice. Okay, so that's a weak entity. Cardinalities. We talked about this, but let's review it. One-to-one relationship is simply anything that has a one-to-one relationship most of the time is put into the same table. I have one first name. I have one middle name. I have one last name. I have one social security number. That should all be on the same record. I have a one-to-one relationship with first name, middle initial, last name, social security number. That kind of stuff. So when you asked the question earlier, how do we know about breaking stuff out? Start with one-to-one relationships. What describes me? My name, my middle initial, my last name, my social security number. Those are all attributes. My height, my weight, my age, my date of birth. All those things describe me. I only have one of those. I only have one height, one weight, one date of birth, all that stuff, and there's no multiple values in there or anything. So that stuff could be safely designed to be stored in one table. One-to-one relationship. Right? So here's one-to-one. Each employee has one locker, and there's actually a couple of ways to do this. You put the employee information in the locker table, or you put the locker information in the employee table. However you do it would be, sort of a judgment call. Okay, and at the SQL for that, we've done SQL commands. A one-to-many relationship, which we've just talked about a bunch of those. In this case, I have an item number that's in my inventory, and I want to create a quote. So I go to a customer and I say, well, hey, look, I got these items in the warehouse. I got a good price on them. I've got 5,000 in the warehouse. Would you like a quote on that? And I can reserve it. So they take that item number and it goes in a quote, and I give that to this customer. Then I go down the road to another customer who's also interested in the same thing. I create another quote, and it includes that item number that I'd used in the last place I went to. That item number shows up in more than one place because it's on a quote for company A and it's on a quote for company B. One to many. So there's one item number, but it shows up in many places. And there's a SQL statement. Many-to-many relationships, and this author calls an intersection table. I used to call it a transaction table, but intersection is fine. Our sales table, in this case, it fits the bill. That's an intersection table by the definition that they're using here. It's a way of creating, if I had a relationship between employee and customer, that would be a many-to-many relationship, because this employee should serve many customers. And this customer should be served by many employees. I go into the car dealership, and I talk to a different guy this time, and I talked to last time. That should not be a problem.
And hopefully, the guy who's selling cars sells more than one car to more than one person. Right? So that many-to-many relationship doesn't work. It's very difficult to store a many relationship in a relational database. So what I do is I break this apart. Undo is a great thing. I break that apart into, I have a one-to-many relationship where I have one customer who hopefully will buy many things from us. And I have one employee who hopefully will sell many things to many people. I break that relationship apart into two one-to-many relationships, and it works much better. It's much easier to store, much easier to manage. That intersection table, don't get too hung up on the word intersection table. It could be called a lot of things: transaction table, association table, intersection table. But just by inserting a table between two things that are part of a many-to-many relationship, it breaks it into one-to-many relationship. There, student courses, student classes. In this case, student 100 only takes one class, but student 200 and student 300 take two classes each. So by creating a schedule or a schedule table like we did, this was like the first thing we did way back in the beginning of the course. We put a schedule table in the middle. It breaks those many-to-many relationship into two one-to-many relationships. So I have one student can sign up for many classes, and one class can have many students sign up for it. How are we doing with this? Remember recursive relationships? This is, they use doctor treated by another doctor. The one that I like is employees and supervisors. The supervisor is an employee, and so the supervisor's employee ID shows up in the employee's record for who their supervisor is. So you have one table, but actually have a relationship within that table. That's a fun one. Any questions? These are design issues that you'll face when it's great to do the initial layout of a system, and then you're going to create the entity relationship diagrams that show how everything fits together. Then when you get on the edge of the cliff, and now you're going to jump in, right? And you're going to start actually doing something and building the data and building the tables and all that stuff. These are things that you're going to address. How far do we normalize the data? Do we have to denormalize any of the data? What do the relationships look like? Are there any many-to-many relationships that need to be broken down? You'll find that out when you start laying out your ERDs. If you see a crow's foot on one side and a crow's foot on the other side, you've got to break that apart. Because otherwise you're going to have a hard time storing it. You're going to break. That's really easier. The normalization issues tend to take care of themselves if you just break apart the many-to-many relationships. By doing that, you will solve a lot of the normalization. If you don't remember that, third normal form is every candidate key has to do, even if you don't remember that stuff, you start breaking apart those many-to-many relationships, you'll be fine. Questions? Any questions? No? Are we good?